Hello everyone, my name is Saurabh Kumar and I welcome you all to my video series of AWS. We are now in part number 16 where we are going to talk about ELB, Elastic Load Balancing. So in this particular session, we will be having an overview of ELB. Then we will be going for the practical part where we will see how to create target group, how to create ELB. So overall this session, after completing this session, you will be in a condition of understanding what ELB is, and you will also learn practically how to create ELB for your beta enrichment. So let's begin. First thing, we are going to see what is elastic load balancing or balancer R. What is ELB? So ELB is nothing else. If you see this picture also, you will get very easy understanding on it, that ELB is something which is doing the load balancing. Let's say that you have two EC2 instance, you have created two server, or maybe you have two web server. This is maybe server number 1 and this is server number 2. You are running maybe same service on both of them. So you want to have some load balance management, like maybe if you have multiple clients, some clients are using tablets, some clients are using computer, some clients are using laptop. So their request is, when it comes to your web server, to have a proper load balance, you are using here a load balancer. So what it is going to do is, it is accepting that request and it is managing those load, maybe by sending some request to this instance and some request goes to this instance. It is like you have two people, so this guy is distributing their task, distributing their work, so that they will have a bit less load on them. So ELB is what? Automatically distributes the incoming application traffic. Whatever application you are running there, it can be a web server, it can be a file server, it can be any other type of service running over there. So whatever service or application traffic is coming to that machine, it will be automatically distributing them, and those application, or what exactly it can be. So it can be maybe multiple instances you have, like one instance here, one instance here, or maybe you can have containers. So if you want to have a load balance among multiple container, you can also use ELB there, Elastic Load Balancer. So here you see this is client timeout. Client will be first, their request will be always going to ELB, and ELB will be forwarding that message. It is in the backend to the actual maybe EC2 instance, or maybe your container or Docker or anything like that. Let's have a look on it in a more detail. So here maybe you have a server. This server maybe is running your website, because in previous session we guys have learned about that, how to host a website. Maybe you have run maybe Linux on it. You have a Linux machine, Linux instance. On the top of that, maybe you are running Apache. By using Apache, maybe you are having a website on it. So this website will be obviously be accessed from the client. So how it is generally right now, it is going to be connected with the internet, and that, so this machine is going to be first directly connected to the internet, and then from that internet, any person, any guy who want to access, they will be accessing it. So this is client or a user who is accessing that service. Here is your EC2 instance, server 1 running with your Apache, with your website. So this website is being accessed. That's the normal condition, and up to this point we have also seen it in practical way. Now if your number of clients are many, maybe you have thousands or maybe millions of users who are accessing this server or the service which you are running there. Maybe you are having a website. Let's say that you are having a website for doing online shopping. So maybe when the time you have started your business, that time the traffic was less, the load was not enough. So you have started your business with one server, and that instance you created on Amazon. That instance is connected to internet, and your customers are using their laptop or computer to access this service, to access this website and doing the online shopping. But later on, maybe the customers, number of customers has increased, so now the load are many. So if you think that one instance will be sufficient to take a load of all the client once there are many number of client, then it will not be good. So in that scenario, what now we can look for each, maybe if you have multiple customer here, now you have multiple customer who is going to access this service, so maybe this one server will not be sufficient to provide the service. So now what to do? What can be the solution? Obviously we have to look for one more instance here, so that now it will be there will be two instances who can provide the service, and there will be a load balance between them. So now what we are going to do now is, we are going to put maybe one more server here. So maybe I can call them server number 2 rather than calling server 1, and this one maybe I am calling it server number 3. So now I have 3 servers. All these 3 servers I will maybe put the same folder which contains my website, or maybe I will just put them in a different way. Maybe these are just instance and a storage is somewhere else. This storage is connected to all this instance. So they all are having maybe exactly same website. For example, my website name is, let's say that my website name is clickcard.com. So that website will be accessed by this all, right? Now if any customer sends a request, for example this customer is sending a request, what will happen by default? Maybe this request goes to this. Maybe another customer want to send a request, this request also goes to the same machine. Maybe this request also goes to the same machine, this request also goes to the same machine. So what will happen? This machine is having overload where others are having zero load. So to solve this problem, now we need a load balancer. So what we do now, let me remove the all ink from here. Now what we are going to look for the option as a solution, that we are going to put a load balancer here. Now what is going to happen, that all of this machine is going to be connected with this load balancer, and our any of the request coming from any of the customer, it will be reaching to the load balancer, and load balancer is going to do what? It is going to automatically distribute those load. So maybe if there are, let's say that first customer sends a request, so it goes to this computer. Then the second customer sends a request, this will go to the second customer. Then third customer sends a request, it goes to the third computer. Then fourth one sends a request, it again goes to the first computer. So it is now automatically distributing the load, and that's how the load is being balanced. What is happening? That it is balancing the load. Now before we were not having load balancer, all the load of the any of the site request or something, we are going to a single machine. Now because we are having a load balancer, this load is being distributed, the traffic is being distributed, and we have a proper load balancing here. So what we can see here, overall the benefit we are getting, that multiple customer, maybe you have a customer A, customer B, customer C, their loads, their requests are being automatically distributed, and that's how our service is not going to be like in condition of any DOS attack or something. Also it will be able to handle those situations. In case somebody is sending millions of requests also, at least those load will be distributed and it can handle those kind of requests as well. Now, what are the main use of having the ELB? Where we can use ELB? So let's have a look on that. ELB, Elastic Load Balancer, can be used for web hosting. So maybe all these three are hosting your website. Maybe you are having a website and that website is hosted on all these three servers. There you can use ELB. There we can use the ELB here. Or it can be also used for file hosting. Maybe you want to keep some file and that file is being accessed by multiple customer, multiple users. Then also you can have the Elastic Load Balancer there. It can be also for application sharing and hosting. So these are the basic use, or you can say these are the condition where we need or we use the ELB, elastic load balancer. So ELB is nothing like, it's same like so many different load balancers are, like Microsoft is also having a load balancer called as a NLB, network load balancer. So for example, if you have two IIS server, you can put them in a one NLB, and what will happen now, their request will be distributed. If any request comes, it will be distributed to two IIS server. Maybe you have one IIS server here, one IIS server here. So the request is going to be distributed. Similar to that, Amazon has given the name elastic load balancer. It is a load balancer which is elastic as well. Next point here is, you can see load balancer are of two type on the basis of their label, how they work. So there are two type. One is called as a application layer load balancer. So generally it uses L4 up to L7, layer 4 up to layer 7, all type of traffic will be passing through it. And one category we call it as a L3 network, L3 network balancer. So these are the two type of load balancer. Another way, in a different way, we can also see that load balancer is of two type. One is software based load balancer, one is hardware based load balancer. Software based means you will be having any computer running there with some specific application or a role or a feature which will act as a load balancer, like the one which I was explaining you here, network load balance from Microsoft. It is nothing else, it's just software load balancer. You have a machine where you are running Windows Server. You have this machine running Windows Server. On this we use a role. We make a role here, and that role will help this machine to act as a NLB, network load balance. So this type of load balancer which is available as an application or as a software, we call it as a software load balancer, where you also have a separate physical hardware device, like the way we buy a router, we buy a switch, we buy a firewall. Similar to that, we also have a physical hardware device which comes with the function of load balancing. So this type of load balancer will be called as a hardware load balancer, and there are many company who makes hardware load balancer, and some examples are Barracuda load balancer, F5 load balancer. So these are some of the one of the top level, you can say, hardware load balancers are. So generally when we talk about any enterprise organization, they always prefer or they use hardware load balancer, not the software load balancer. Software load balancer can be just used for a very small organization or any specific person, business or something like that. But any big organization, big enterprise, they always prefer, they use hardware load balancer, and that hardware load balancer is going to balance or do the load balance between or among multiple instances running there, or maybe multiple server running there, or maybe multiple Docker runs there, multiple container running there. So there they use physical or hardware load balance. There is a problem with software load balancer, that you know that software load balancer is running on first of all a physical hardware, then you need an operating system, then you are using the load balancer. So if any problem happens to your hardware device, if any problem happen to your operating system, if any problem happen to your application, this load balancer cannot work. This load balancer will be having problem. But if you are using hardware load balancer, there is no any specific operating system, or there is no such kind of interface, or less kind of problem will be there. So that's why the preferred thing is hardware based load balancer. But the one we are talking about, ELB, ELB doesn't come under the category of software, not in even hardware. We can keep it in a category of cloud based. So we can call it cloud based load balancer. It is a load balancer which is on the cloud. So you don't get any specific software, you don't get any specific hardware, you just get a cloud interface where from you configure the ELB, and that ELB will be working or helpful for your running services, for running application. So all these things we are going to see today itself in this particular video itself, that how to configure ELB for our running instances. So that is what I was talking about. Let me mention here, AWS ELB is which type of? It is a cloud-based elastic load balancer. Now let's have a comparison here. So there are, as I mentioned, types of load balancer. One, we have layer 4, or actually Amazon call it as a layer 4, but in actual way it works at layer 3. But just because not only it checks IP, it also checks the TCP, that's why it is called as a layer 4 from the Amazon. So Amazon call it layer 4 category of load balancer. And the other one, which only checks application, comes under the category of layer 7 load balancer. So we have two category, layer 4 load balancer, layer 7 load balancer. What layer 4 load balancer does? So it supports TCP and SSL. Where if you talk about layer 7, it only supports HTTP and HTTPS. So any service which you are offering by the help of protocol like HTTP or HTTPS, then you can use a load balancer, that is layer 7 load balancer. But if you are offering or you are having a service which require TCP to provide the service, there we will prefer, we will be using layer 4 type of load balancer. One example I would like to tell you. For example, you have a computer, maybe you have two computer, and both of them are running a website. So this service of website is being offered with the help of which protocol? We always offer a website through the HTTP or HTTPS. So HTTP, or I can use their HTTPS. So for a website, what kind of load balancer can be helpful for me? What kind of load balancer I put here? So I can use layer 7 load balancer because it supports already HTTP and HTTPS there. If you are having maybe here a file or any other kind of things running, maybe container or Docker or anything else which may require TCP, then we will be using layer 4 type of or network type of load balancer. Maybe you have for IP address or something like that, then we will be using layer 4. So layer 4 is doing what? Incoming client connection bound to server connection, where if we talk about layer 7, connection terminated at the load balancer and pulled to the server. When we talk about layer 4, no header modification is required, or it doesn't modify any header information, where in layer 7 header may be modified. If we talk about layer 4, proxy protocol propend source and destination IP and port to request, where in layer 7 connection will be forwarded for a header contains destination client IP addresses. So there are some basic difference between layer 4 type of load balancer and layer 7 type of load balancer. Let's have a look on the ELB architecture. How does it look like? If I talk about architecture of ELB, how it is being used? So here you see in this diagram what is happening. We have here ELB VPC, meaning that you can have a separate virtual private cloud network of multiple ELB, and this ELB is being routed with the help of Amazon S3. Amazon S3 is nothing else, it's a Amazon DNS service. So any request comes to you, maybe you have multiple different website running. So when you type the name of the website, it comes here, and on the basis of their domain name, your DNS is going to route it, that either it should go to this ELB or either it should go to this ELB. Then this ELB is also having connection with multiple EC2 instance. Maybe there can be 2 EC2 instance, 3 EC2 instance, 4 EC2 instance. This ELB can also have multiple EC2 instance. So this is how the ELB works for any enterprise organization. Let me explain you with another picture here, which will be giving a better explanation. But before I go there, you can also see one more difference. Maybe this ELB, you are using on a specific US based A1. What does it mean? This is US based is a region. 1A is defining the availability zone. So If I talk about ELB, ELB is a service which is region based service, meaning that ELB can, whenever you are creating ELB, you have to choose your region and you have to choose your availability zone. If you remember, in a very first part of this training, we have discussed about that the services can be of two type, region based or global. So ELB is a region based service, meaning that where your EC2 instance is, whatever region you have created your EC2 instance. For example, I have an EC2 instance running in my Asia Pacific AP and maybe Mumbai. So this is my region. So where do I need to create ELB for this EC2 instance? I do have to create the ELB also into the same region there itself. If I create ELB in a different region, that ELB will not be able to work for the EC2 instance which is in different region. So keep in your mind when you are creating a new ELB, when you are making an ELB, that you are creating ELB in the same region where your EC2 instances are, which you are going to put in the ELB. Next thing here, you see that Amazon ELB family. There are three families are there. One is application load balancer, which we have explained. Application and network, these two I have already explained about. So this one uses HTTP or HTTPS with the virtual private cloud, where this one uses TCP with the within the VPC. Where when we talk about classic load balancer, the third category, it is something like previous generation for HTTP, HTTPS and TCP. So it works for all together and it is a for classic network. So by default, when you are actually going to create any new ELB, it will be following this category, and we will see this all things practical. So I will explain that time as well. So as of now, what we can see here that Amazon ELB families can be three: application load balancer family, network load balancer or classic load balancer. Now let's try to see with another picture here. When we are using classic load balancer, CLB we call it, classic load balancer, it is a default for EC2 instance. Whenever you have EC2 instance, it is going to be automatically there, and that is the default condition. So here, for example, this is a user, he loves cloud computing. So this guy will be talking to the ELB, and this ELB can be working for multiple EC2 instance. You have one instance, two instance, three instance, like that, and these all three instance load are being managed. The traffic of this EC2 instance are being controlled by the ELB. Or you can also have a different example, that maybe you have two different service running. So you can have one ELB for one service where you have maybe three instance. So this is one service here, and this is another service. Maybe you can see here the name also. Maybe your main company site is example.com. So now within the example.com, maybe you have categorized it. One is orders.example.com, so you have set a separate ELB for it, and there are three instances running order.example.com website, where these three instances are running images.example.com. So you have a separate ELB for these three EC2 instances. So this way you can have multiple ELB also for controlling the traffic of multiple EC2 instances. For example, you have started a company. Maybe you have started a company of providing online shopping. So maybe in your company you have two categories there. One is maybe, let's say that electronics item. One place you are selling electronic item, and one place maybe you are selling grocery item. So you are going to have maybe separate URL for them. One you will have the name electronics.onlineshopping.com, and that website, those information related to electronic things you are going to keep on these three instances, and their load will be managed by this ELB. So whenever somebody is looking to buy any electronic equipment from your website, their traffic will first go to this ELB, and this ELB will see where to send this traffic, either this one, or either this one. It will be managing the load on it. But what kind of information it will contain? Only about the electronic items. Maybe you are selling a laptop, computer, printers, all those kind of things. If somebody say grocery.onlineshopping.com, so your grocery related details are maybe stored on these 3 servers. So you have a separate ELB for that. So any request comes with grocery.onlineshopping.com, it will be going to this ELB. Who is doing this task? So obviously there is going to be also a DNS, and in Amazon the DNS we call it as a root 53. So that root 53 will read the name, and by reading the name it will understand, oh, the name is glossary.online.com, meaning that when it says glossary, it will redirect that traffic to this ELB. This ELB will, maybe the first request it will send to this guy, the another guy request who want to also buy grocery items, it will be going there, the third guy request will go there. So now this way you are managing the traffic. You have already separated the traffic of all electronic item to this area, all the grocery to this area. Now in the grocery also you have multiple instances running, and those multiple instances traffic will be managed by this ELB. I hope it's clear to you all up to now. So let's move to the next now. Here we see the example of application load balancer. If you have application load balancer, how does it work? So maybe again you have a website running example.com. In that website maybe you have 2 different area. One you have separated for only taking the orders, and one maybe you have the gallery where you store all images. So you have 2 part there. So your site will be looking like example.com/images or /orders. So when you say /order, maybe those requests will go to this instances, and /images request will go to this instances. For example, let me show you something like that. Let me go to my Google Chrome. Let's say that there is a site called sms.saipali.education/ maybe I have, this is my site, just for example. So here you see it has 3 parts, 3 areas. You want to do on this site SMS function, LMS function or OES function. When you say maybe OES, I want to go for OES. So when you click on it, what you see here, /OES has been added. If I go back, if I click on SMS, what is happening? /login is being added there. If I go to LMS, let me show you what is going to happen. So /LMS has been added in your URL. So this is what I am trying to explain you here, that in the same, on the same site maybe you have separate area, /orders, /images, and therefore each you can have multiple instances running to only manage. Maybe all the online exam system is running on these 3 instances, all the online LMS learning management portal is running on this one. So this way we are able to use application load balancer. Application load balancer allows for multiple services to be hosted behind a single load balancer. You have a single load balancer here. In the previous example what you have seen, there was 2 different ELB, because the name was like this. Before your domain name, this was like that, orders.example.com. So we were required to have 2 different ELB. But here you can, if you are adding / and then you are adding some virtual directory, we can call it like a virtual directory. If you guys have experience of creating any website, you know, you create a main website and then there you add some virtual directory. So if you have this kind of condition, you can go for the application load balancer, and there you can use a single load balancer to have or to allow for multiple service to be hosted behind a single load balancer. So now let's see some more detail about it. When we talk about ELB, first of all, it is a new thing, and it is a feature rich. It has so many features inside of it, and it is an example of layer 7 load balancer platform. Next point about ELB, when we talk about, it is providing content based routing allows request to be routed to different application behind a single load balancer. So we can use a single load balancer to have multiple different application there. Then it support for microservices also and container based application, including integrated with elastic container services, like the way I was talking about container, Docker and all. So it support for them as well. And it also support WAF, that is called as a web application framework. So now one more thing I would like to add here, that is components of load balancer. When we are using a load balancer, we will be talking about one thing that is called as a listener. What is listener is? Listener is nothing else, it's like a service or something which is running to help the load balancer. So whenever we create a load balancer, we also have to activate the listener, and we have to define a protocol. That protocol will be helping the listener to do a health check of whatever you have in your load balancer. Maybe you have a load balancer from for EC2 instance. So listener will be checking the health of those all EC2 instance. Maybe you have a load balancer for multiple IP address of computer. So your listener will be checking the doing the health check of all those IP addresses. If you have created a load balancer for any of the ECS, then it will be doing the health check for all of them. So listener is doing nothing else. Listener uses a protocol to check the health status of the machine, of the IP address, of the service. So for example, let's say that you have created a load balancer, you have created ELB here, and this ELB is connected, or maybe you have we also create a target group there. So now this target group is having maybe multiple instances. Maybe you have 3 instances, 1, 2 and 3. So what listener is doing, listener is something running on your load balancer. That listener will be requesting to those all instances, whatever application they are running with, to check. There is some interval time, that after that each interval it sends some message to just check that either these machines are active or not, they are able to respond or not. If they respond, that means they are alive, they are okay, health is okay, they are healthy. If they are not responding, it consider them as unhealthy. And if the response like 5 times it has not responded continuously, they consider it as completely like it is no longer available. So when it is unhealthy or no longer available, any request coming for any service, your load balancer is not going to send that traffic to the machine which is unhealthy or not functioning well. So that is also a task of load balancer. If I repeat, load balancer is having a function running there called as a listener, which keeps sending a message to this all EC2 instance or IP addresses or whatever application you are running there to check and verify the health status. We call it like technically we call it heartbeat. So it checks heartbeat of the instance, it checks the heartbeat of the ECS to make sure that the device, the target, is either active or not. If it is not active, obviously the request will not be forwarded to him, because they know that even if I forward any request to that particular EC2 instance or ECS or IP address, it's not going to respond. So they are also doing this task, and this task is done by load balancer with the help of listener. So now to see whatever we have discussed, or to get practical on it, we have to move to the AWS console. We are going to perform the practical part, that how to create a load balancer. To fulfill or to achieve the practical of this, we have to follow some previous task as well. So first thing what I am going to do is, let me move to the next slide. Let me tell you what we are going to do here. Very first thing, we are going to create an EC2 instance, because without EC2 instance, where we are going to do the test of load balancing. So we will create EC2 instance. We can use any. So I have choose to go with the T2 micro because it is free eligible. I will be using maybe Amazon Linux, but you can do it with the Windows machine, you can do it with the Red Hat Linux or anything. And basically I am going to test the load balancing with the service running web service. So I will be having this machine where already a website will be running. So we have learned already these things in a previous session, that how to make Amazon Linux install or EC2 instance, how to launch EC2 instance where it is already having HTTPD service running there. So you just need to add this information in your EC2 instance detail when we are creating. So let's do that. Let's check for it. So I am going to use my browser and I am going to log into my AWS account. Sign into the console. And I'm going to use my user account, maybe this one, to log in with. So I'm logging with the root user. Now what is our plan is to create, first task is to create EC2 instance. So I go to EC2 instance services. Right now I don't have any running instance, no any elastic IP, no screenshot, no volume, no key pair, nothing. So I am going to scroll down to click on launch instance. These are steps I am going to be a bit fast here because I have already explained these things before. So I am going with the Amazon Linux. Instance type I am going with the T2 micro because it is free, tier eligible. In the configuring instance detail, here one thing I have to do, that I have to add something here. When I scroll down here as a text, I am going to add something, that is nothing else, this command, so that when this EC2 instance will be launched, it will already have the Apache service running there. It will already have the update. It will already check that or make sure that the Apache service will be automatically started. So let's do that. Here I need to type the way it is, bin/bash. Here we have yum. Yum is we use in Linux to install something. So yum install -y. Then I say yum install -y, and which service, HTTP. This is the package I want to install, HTTPD. Then I say service HTTPD, and to make it a start, I just say start, so that this service will be automatically started. And then just to check it, chk con chk config HTTPD on. Now I go to add the storage. So by default it is going to take 8 GB space because it is a Linux instance. Tag is optional, I am just skipping for now. Security group, maybe I give the name Linux security group 01. Linux security group 01. Here SSH by default is added in this security group because we will be accessing this EC2 instance with the help of SSH. Let me also add one thing, that is HTTP. Why? Because I know that I am going to run a web service on it, so I need to allow HTTP. I make sure that it goes to anywhere. Anybody can access HTTP site from this EC2 instance. I just review and click on launch. I am going to create new key because I don't have existing. So I give the name Amazon Linux key. Download key pair. And then I click on launch instance. So this way we have just created EC2 instance, view instance. So here we can see the instance is getting ready. A state is right now pending. A status check is initializing. Meanwhile, I can give the name of this machine Amazon Linux for web. This is the machine I have made, Amazon Linux, to host the website on it. So let it get this machine ready. Once this status checks will become complete, when it will be showing 2 by 2, then we will be able to perform the next task. Meanwhile, if you want to connect this instance, click on connect. Let me connect with the browser based. I have already explained all other connection method in my previous session. So maybe I want to connect it right now browser based. So I click on connect. And here I am going to get the console of that Linux machine which we have created. Here it is, EC2 Amazon Linux 2 AMI, and I am here. Right now if I check service HTTPD status, if I want to check maybe the status of HTTPD service, let's check. You can see the status is active and running, means Apache is already running there. The Apache HTTP server is active and running. If it is active and running, what does it mean? It means that if you know the IP address of this machine, this is the public IP address, right? So if I copy this IP address and I open in my browser, there will be the default page coming for that particular computer. So this machine, right now it is saying initializing still, it's not been completed. So once it will be completed, even right now you can see the test page is appearing, meaning that this EC2 instance is already running the web service. It has already the default website, this one, which is appearing with the help of public IP address. That is the public IP of this instance. It is now 2 by 2 checks and it is ready to use. Maybe let's try to put our own customized website rather than having this test page. So for that, what I'm going to do is I'm going to make a website here. Let me just retry to connect on it. So as of now, if it is coming the default page, if I want to have a customized page there, what I have to just do is here that I have to create a HTML file. So if you have HTML file, you are going to upload it or download it on this machine. If you don't have, like right now I don't have it, so I'm going to just make a various I'm just going to run maybe very few commands just to have a website, that's it. So for that, what I'm going to do is, we know the default location. So let me go to the default location of the HTML file. So I go to cd/var/www/html. That's the default location of all HTML file which is being shown on your website. So there I am going to create a new file of HTML and I want to run some code there so that the website will appear accordingly. So now I'm going to create a file there. Creating a file, the command is nano. I can use nano editor or I can use vi editor or vim editor, whatever it's supported. So maybe I'm using nano editor. So I put nano space, the name of the file. So maybe the name of file I want to have index.html. So this is the command and I have to hit enter. But because I'm login with, you see, EC2 user, not the root user of this machine, so I may get error. Let me first show you. So if I hit enter here, it is opening that file, but it will not allow me to save. You will see that. So if I type here something, maybe I just type here HTML and I want to save. So saving, I have to press Ctrl+O. With the name index.html, I hit enter. You can see error writing index.html permission denied. So that's why what I'm going to do is, I say no. This time when I'm running this command nano index.html, I am starting with sudo command to get the privilege and to execute this task. So sudo nano index. Now I am typing my command here. So HTML, I am making a HTML file. There, maybe I am making header. So I put header 1. Header 1, maybe I just want to write that welcome to my test page. Header close. And then HTML close. Or maybe just I want to add one more thing, that is title. So maybe title I want to add here is Saurav wave, title close, like this. Now I save it, Ctrl+O, index.html will be the name, and Ctrl+X to exit. So I can see by typing ls that there is a file now, and the file name is index.html. So once this file I have created there, let us check what website appears here. So I refresh that website IP. You see now the new website is appearing with the name, title is Saurabh Wave, and the header is welcome to my test page. So this is the site we have created on our instance here, and this site will be visible to all of you, or we can just give this IP to anybody and they will be able to access my website from anywhere. So this was the normal scenario. Now we are going to learn now how to use the NLB. So right now all the load is obviously going to only one instance, the one which we are having here, and now we are going to see how to use NLB. So for that we have to go to the services, or you can go to just console home. If you go to even EC2 or somewhere, here if you scroll down you will be able to see an option there called as a load balancer in the drop down of load balancing. If it is showing you like that, you just have to expand it. You will get load balancer and target group. So click on load balancer. Right now it is going to show you there is no any load balancer. You see, you don't have any load balancer in this region. So which region it is? Ohio. Keep in your mind that the EC2 instance you are creating and everything which you are creating, always you have to make sure about your region and availability zone. If I ask you which region I do have created that EC2 instance, so we can check it by going to new AWS maybe here, and let me show you the region for my EC2 instance. So if I am here in the region of Mumbai, I can see here that is 0 running instance. So this way you can be also getting confused that how come I created an instance and it is showing me 0. The reason behind that, the region you have selected is having 0 instance. So you have to go to exactly the same region, and then you see here how many running instances you have. So you see running instance is 1. You can check it also from here. So EC2 instance and ELB, these all are the region based service. So here you see this is the EC2 instance I have, which is in availability zone US East 2C. Check here. When I am here talking about the load balancing, when I am creating load balancer, I have to also make sure that I am going to create in the same region. So right now there is no any load balancer in this region. So what I am going to do is I am going to create a load balancer. But before I go to create a load balancer, I do also need to have target group. So that's why I will be first creating a target group and then I will go to the load balancer. So first I go to target group. Let me explain you how to create target group. So you go to click create target group. Target group means you are creating a group where you will be putting all those multiple EC2 instance or IP addresses which you want to be managed by the NLB or ELB. So what target group you are making? You want to make a group of instances, multiple instances, or IP addresses, or lambda function. Lambda function is like a serverless services. So we haven't discussed about it, but at least these two you can understand. One is related to IP address, one is related to instance. So our current scenario is maybe I want to do it on the basis of instance. So I will choose here the target type instance, meaning that my target group will be consisting of multiple instances. So it supports load balancing to instances within a specific VPC. I say okay. Then down you give the name of the target. So maybe target group name, I give the name that is Saurav Wave Target Group 01. That's the name. Always whenever you are giving anything name, put some name which can define about it. So that's why I have given the name. My website is Saurav Wave and I am creating a target group for it. So I am giving target group and then 01 is the number. Maybe if tomorrow I want to create another target group, I will give 02. Then it is this target group always uses the protocol. So the protocol, it can support HTTPS, HTTP, TCP, TLS, UDP, TCP, UDP. So depending on which type of target group you are creating. For me, my condition is I am making for website, so I go with HTTP. My website is not secure also, you see. It is using HTTP right now protocol, so I go with HTTP. VPC is default, by default. If you don't have separate VPC for it, you go with the default. Then the health check. So for health check, it is going to also use the HTTP protocol and the path is root folder. Tag is optional, so I am leaving it default. I go with the next. Now here is the available instance because we are making a target group of multiple instances. So what are the instances you want to keep in your this target? So right now I have only one instance. This instance I'm talking about. You see instance ID I06 ending with FC. I06 ending with FC. So this is the instance I have only one. If you have multiple 2-3 instances, you will check all of them and then you will just click on include as pending below. So they all will be added here in the target. Right now status is pending, don't worry about that. A state is running. A state is running means this EC2 instance is running right now. It will be checked or attached with the help of port number 80. Security group it is using is LSG01, Linux Security Group 01, which we have used on this instance. The zone it is in US EC East 2C and the subnet ID is this one. So I go with create target group. So this way successfully created target group with the name Saurav Wave Target Group 01. Here is the name of the target group. This target group is using protocol HTTP port number 80. Target type is you have choose for instance. Right now there is no any load balancer here. VPC ID is this. If you want to go inside of the target group, click on it. Inside this target group, you will be able to see the detail of this group. Health check setting. It uses HTTP protocol. Path is this. Health threshold. You see here. Health threshold is telling that 5 consecutive health check successes. If this any of the instance will be sent with the 5 consecutive messages, and if they respond, if they have it, they send the health message, meaning that they will be considered as a fully healthy. Timeout is 5 seconds. Unhealthy threshold is 2 consecutive health check failure. If 2 consecutive health check gets failure, if they don't able to respond it back on time, they will be considering it, that instance will be considered as a unhealthy. Interval is 30 seconds, means after each 30 seconds this message will be sent. Success code is 200. Attributes are here, details are here. The load balancing algorithm, it uses round robin. Round robin is actually algorithm also used by DNS, so we call it DNS round robin algorithm. So the same method is being used here. The load balancing algorithm it is going to use is round robin. Round robin means first request goes to the first, second goes to second, then the third goes to again first, fourth goes to second, fifth goes to again first, like that. That is called as a round robin mechanism. If you go to targets, you can see you have one instance running, and right now status is unused because this machine is in target but it is not in use right now. It will become in use when you create a load balancer. So let's now move to the load balancer. In the load balancer, right now we don't have any load balancer, so we click on create load balancer. You see, now we have discussed already in today's session itself that load balancer can be application load balancer, it can be network load balancer, or it can be classic load balancer. So for me, because I want to make a load balancer for my web service which uses protocol HTTP and HTTPS, I will be going with the application load balancer. So I click on create. Now it is asking me to define any name to this load balancer, so I can give any name. Maybe I am giving the name sort of wave ALB, application load balancer. I am just giving the name to this load balancer, Web ALB. It will be using a scheme of internet facing, means it will be this load balancing will be working on internet. Anybody who is accessing my web service through the internet, it will be using IP version 4 type, IP version 4 IP address type. Here you see about the listener, what kind of request and listener will be using which protocol. So by default it is going to use HTTP, but later on, in case if you want to have SSL, if you want to have secure site, if you want to implement HTTPS, you are going to add listener and you will add HTTPS. So as of now I go with it. Now it's time to choose the availability zone, because you are making a load balancer, right? So you have to choose the availability. So obviously one thing keep in your mind when you are choosing the availability zone, you check your instance which availability zone it is running with, US East 2C. So here you will always use that one, and then you can use any others or maybe all others also, but keep in your mind you have to use this one, at least the one which is the zone, availability zone, which is already being used by your instance. So I have choose one, this one, and one I can choose any other, and then I go with the configure security setting, configure security group. So I don't have to create again security group because I already have created one. So I will go with this Linux security group 01. Configure routing, how the route will come here. So for that I am going to again use the existing target group, and this is why I created already a target group. You remember before I came to the load balancing, creating load balancing, I already created a target group so that I can easily choose here existing. Otherwise I would have to create new target group. So because I have already created target group, I will just choose existing target group. So when I select the target group which I have created, it is already taken all the other information, like it is the target type is instance I have choose, protocol it will use HTTP, port it will use 80, health check it will be using HTTP. All those detail has been taken by itself. Now you go to register the target. Done. This is the review. Next, check the review here. about it. So here you also see you are making a NLB where the health status, healthy threshold is 5, unhealthy is 2, timeout is 5, interval is 30 seconds. So those are all informations are here. The protocol it is going to use is HTTP. Health check protocol is also HTTP. Port number it will use is 80. Target group name is Saurav target group 01. So now I am going to click on create. So finally successfully created load balancer. What the name of load balancer is? Saurav Wave ALB. Close it. So here you can see now this is a load balancer created for us, for our website, and this is the DNS name given to this load balancer. So anybody who want to access now my website which was being accessed with only IP address before, they can be also accessing it with this domain name, because if you access it with this name, that means you are not defining the IP of any individual computer. So maybe in behind, let me explain you why this method. For example, here I have one EC2 instance, here I have another EC2 instance. Maybe this one is having IP address starting with 3 dot something something something. This one is having IP address starting with 15 something something. So if you give this IP address to your client to access your website, that means their request or their load will only come to this computer. If you give this IP address to them, the only load will come to this computer. So that's why now what we are going to do, we have created now ELB, right? So this ELB is also having its own name, and you can even set the IP for it. So whatever the name is here, that name you are going to give to your customer. So your customer will be sending request to the ELB, and then ELB is already having the target group. Target group is containing these two computers, so the request will go here and here, it will be distributed. So what is the address for this ELB? That is what I am showing you, is this one. So if you copy this name also, no, if you just select it, this name, copy it by pressing Ctrl C, and if I paste this name in my any of the browser, I will be able to see the same website here also. Saurav website, welcome to my test page. So if anybody is accessing my website with the help of this name, this DNS name, that means they are not defined that the request will go to my EC2 instance 1 or EC2 instance 2 or 3 or 10, whatever number of instance I have, doesn't matter. Their request comes to my load balancer, and load balancer will check how many instances they are running inside. It will use round and robin mechanism to send or to distribute the request to multiple EC2 instances. So once we go to now the console, we see the status. Let it get this state in an active mode, so that it will be even giving the better functioning. We are still able to see it, but once it will be in a running mode, it will be showing. Right now it is still in the provisioning mode. Meanwhile, when it is in provisioning mode, let's go to the target group and check in your target group what is the status of your instance. So here you see a status is healthy. Why it is healthy? Because it is running index.html file, and that index.html file is responding to the health check message. When it is responding up to continuously 5 times, then it will be considered as a healthy. If it will not be responding, it will become unhealthy. So right now the status is healthy. This is the instance name. This instance is working in this target group. This target group is being used by my load balancer. My load balancer name is Saurav -ALB. This is the name, and this is the DNS name which we are using. A state is now active. So everything is okay. DNS name is this one. You can copy this name and you can share with your client, your customer, and or later on you can customize this name with your purchase domain name or something, so that your load will be coming to the load balancer, and then load balancer will be redirecting or distributing that load to the multiple instances. Now one more practical let's try to do, that what if my target group machine, which is right now showing healthy. What if I go there and I delete or maybe I remove that index file? Because right now I'm not going to switch off or something. So what if I remove that index.file? Do you think that if the when we talk about the load balancer, we have a listeners, right? So in the listener, as we discussed, it is sending every 30 seconds it sends a message to check. So if it will send a message, it will wait for the response, and if that guy is not going to respond, what will happen? You see, this is my NLB, this is my ALB, application load balancer. It is using listener. Listener is what? A listener checks for connection request using its configured protocol and port number, which is HTTP and port number 80, and the load balancer uses the listener rules to route request to the target. You can add, remove or update listener or listener rules. So right now we have one listener ID is this, and it is using forwarding to Sora web target group 1. In my target, how many computers are there? So check in the target, we have only one instance right now, and that is healthy. Let's do some experiment here now. Maybe I go there, I go to the console of this instance, and I'm going to do one experiment, that sudo mv, I'm going to move that index file from there. I'm not going to delete, because delete means I have to create it once again. We are just testing it, so I'm just going to move that file. Sudo move /var /www /html /index.html. This is the file which is giving me this site, right? This site is coming to me because it is available there at this location. So I'm going to move this file, and maybe I want to move it to /var folder. Once I moved it, meaning that if I go and check there, like let me even show you, cd space /var folder. There if I check ls, you can see there is a index.html file is there now. It has come here. Before it was in HTML folder, under www folder, under var folder. So because I have moved it, or it's something similar like I have deleted, so will I be able to get this website? Let's check. Let's try to refresh. You see, the website is not appearing. That index.html file is not responding. This page, don't worry about this page. This is just the default page. I'm not talking about this. So our website is no longer working now, right? Because maybe the index file has been deleted or moved somewhere else, or any problem has occurred. So when this problem has occurred, what does it mean? If I check in my target group, what is the status it is showing me? Healthy. But it should not show me now healthy. We wait for some moment, and you see now what has it become? Unhealthy. Because the listener of load balancer were checking all the time, and as soon as I deleted that index.html file, this instance was not able to respond that listener message, and because of that, now it has considered it as unhealthy. So maybe if there were two computers, maybe there were, right now I have only one computer, that is the problem. If I were having two computers, this one I deleted index.html, so what will my NLB do? What ELB will be doing? ELB will be forwarding now every traffic to this one. It will not forward any traffic to this machine, because this machine is unhealthy now. When I will bring back that index.html file, or when this machine get restarted, or when everything is okay, now it will become again healthy, and my traffic will start also going to this computer. So let me show you now how to make it healthy back. So maybe I go to the instance and I move this file back to that HTML. Currently, let me first show you. cd space /var /www /html. Right now, if I go to this folder and you see ls, there is no index.html file. So now I'm going to move it back. So I run command sudo mv. and I'm moving /var folder index.html file to the var folder www folder html folder, meaning that I'm not doing anything else. I'm just putting that index.html file back to the default location so that anybody can access that website. Now I have put it. So now let me go back. I try again. Now you see my page is coming because index file is there. It's okay. So now we just have to wait for a moment, because continuously 5 message means 30 second multiply by 5, that much second I have to just wait. When 5 continuously message will be responded by that instance, then my load balancer will consider it as a healthy instance. So let's just wait for a moment to get it done that time, and then we will see the status will change and it will become the healthy instance. So just wait for that many number of second, which is almost 2.5 minutes. And then I will be showing you here in this target group, in the target list, this machine will become healthy. So we can see now the status has become healthy now, because the index file is there, everything is okay. So my machine is responding well and it is in healthy state. So in this particular session we have seen that how to create ELB, how to create target group, and how to add the instances in your target group, plus how ELB is doing the health check and it is giving the health status here. Okay, so let's try to go for one more next level practice here. Maybe let me explain you what I am going to do here. That as of now what we are having, we are already having one ELB we have created. And with this ELB, we are running already only one instance. This is one instance we have, where we have a website. So we have already one ELB added with one target group. Let me call it like a target group. And there inside of that, we are having one already EC2 instance running. Maybe I want to have one more EC2 instance there. So this is my EC2 instance 1. If I write it here, this is my Amazon Linux, let's call it maybe like 1. This is what my target, what is the name of target group? So sort of wave target, something like that. And here this is my sort of wave ALB, application load balancer. So this is the condition right now. Here I have a website, and the website name I have is sort of wave. That is what it is opening. But obviously company is going to have a condition that they will not have only one EC2 instance running, they will have multiple. So now I am going to do one task, that I am going to create one new EC2 instance here. And maybe the name I am going to give to this machine, that will be my Amazon Linux 2. So let's do that experiment. I go to my instances. I launch a new instance and I go with it Amazon Linux instance detail. I have to just make sure that I create in the same availability zone, same region. So I choose 2C because there is my one EC2 instance running. And at down here I have to use some command. The command is this one. So if I copy it, I paste it here. Add a storage. This is the size, so I go with the default. Tag I go with default. Instance I need a security group, sorry, so I will go with the one which we have created for EC2 instance 1. So I go with it. Here is the review, so I click on launch. The key, maybe I will use the existing one. So I have now another instance there. Let me give the name of this instance, that is Amazon Linux this is Amazon Linux Web. So I give this guy name, this instance name 2. For this machine also, let's put some website there. So I go to connect on it. Generally, company will be having the same website on both the machine, so that either you are getting response from this machine or this machine, you will never be able to understand. But for this one, because we are just learning, I am going to keep different website on them, so that you will understand which server is responding you. So here I am going to check first of all service httpd status. It is running good. So we go to cd space / vars /ww /html folder. We are going to create there also a website file, sudo nano space index.html. Here I type html. Header 1. And just for identification, let me put something different message on this website. So maybe here I am typing welcome to my second server page, something like that. So you will understand that second server is responding this time. /h1 header close, and HTML close. Just I am going with the very basic things. Control O to write and Control X to exit. So we are having a site on this machine also. This is the machine. If you want to check one by one both of them, so this is my, let me give the name here 1. This is my first machine, and this is my second machine. So when you check the website running on first, this is the IP. So copy this IP and check. So when you get response from first server, you see the title is Saurabh Web, welcome to my test page. When I go to the second server, I get the copy of the public IP. I paste it here. So this time it is respond from my second server. There is no any title. So I hope now you will be able to understand. I have now 2 server. Both of them are having one website. Company will be having same website. For me, I am using different website. It is containing welcome to my test page. This one is containing second server page. Just to understand that your response is coming from where. Now we have already created a target group, right? So let's go to the target group now. In the target group, we have already added one instance, that is Linux Web 1. So whenever somebody is using, here you see, this is the name of your DNS name of your load balancer. So if somebody access the website by using this DNS name of load balancer, all the time it is going to only be getting response from your first server. Same like that, you see Saurabh Web and welcome to my test page. Even if you refresh, all the time who is responding me back? Only the server 1. Second server is no longer responding. If I want my 2 server to respond with the same name, what I am going to do? I am going to the target group. Right now in my target group, only one instance is there. So I am going to register instance, register target here. And oops, maybe I did some mistake here in the zone. No, it was taking some time, sorry, it's good. So here we see, I am going to add this one also now. And I say include as pending below and register. So once I registered, now in my target group, I have 2 instance. One is healthy, one is still initializing. It's not checked yet. It will just take time. It will be once it will be responding continuously, it will become healthy. If it doesn't respond, it will become unhealthy. So just wait for a moment to get it healthy. So once both of them are healthy, meaning that now my NLB, this address, whenever somebody sends the request to this address, there are two servers behind it. So if I go back to my condition, now my request, any request going to my NLB, before there was only one target group and this target group was only containing one server. Now it has two servers there. So what will happen? If anybody sends a request, one time maybe this request will go to server 1 and another time maybe the request will go to server 2. Let's see the practical of it. So here we are, first request we send and it goes to the first server. Now I refresh, so second request goes, it goes to second server. If third request goes, it goes to first server, fourth request, second server, fifth request, first server, sixth request, second server. Can you see now? I am using the same site. It happens everywhere. When you type google.com, gmail.com, facebook.com, youtube.com, for you, you have only one name, domain name here. But in behind, in the back scene, there is a load balancer working, which is sending your load to different hosts, and you are being responded by different hosts. So now what we are going to do now here, we can see that the response is coming from multiple server. It's not taking care of the IP address. When you choose the IP address, this one is always responding from the second server only. This one is responding only from the first server only. But if you use this NLB DNS name, one time your response is coming from one server, another time it is coming from second server. So I hope you understood now. Load is being balanced. The same domain, if somebody is accessing, load is going to the first server and it is responding. Somebody else is asking for, the load is going to the second server. Now if what happened that maybe if one of this machine becomes unhealthy, let's do that. So maybe I access any one of them, or if I have already access of it, this is 002 instance. So what if I go there, or maybe what I do, I go to instance and maybe I make this instance number 1 a stop. I just stop it. What if I have stopped one server, or maybe it has gone with any problem, or maybe the index file has been deleted, anything. So I'm just making it a stop. Now let's check in the target group. So we go to target group to check. In the target group, right now you see this one has become unused and this is only one is healthy right now. So now anybody is requesting for the website, they will be always being responded back with only one server. All the time when you refresh, only one server is responding you because one server has failed to respond. I hope you understood now what is NLB is doing now. If that machine comes back, so I go back to again instance, I make this machine again running. Whatever problem was there, maybe I solved it and it has become again on. So once it becomes on, it is in pending status, let it become on. Meanwhile, let's check in the target group. So in our target group, one machine is healthy, one is still initializing, you see now. Once it will become healthy, it will start responding also. So my customers, they are looking for my website. Up to now, only second server is responding. Only second server is responding. Only second server is. So all the load, 100% load is on one server right now. You see, I keep refreshing. all my requests, all the loads are going to only one server right now. Till the time my another server also not get healthy, this one doesn't get healthy, all the request is being responded back with only one server. Now you see, it means this server has also become healthy. So my request of few user will go to the one server, few users request will go to second server. So this is working fine now. So I have tried my best to explain how and what NLB does actually. So in this particular session, we have seen what is ELB is, what is elastic load balancing is, how does it work, how to configure it, how to use it, how to create target group and all. So that was all in this session. Now it's time to go for some of the question answer. So the first question from today's topic is, layer 7 load balancer support which protocol or what function it support? You can choose the two options from ABCD. Question number 2, which one are the respective AWS cloud and Microsoft server based load balancer? So I have been taking this name by mistake multiple number of time. By mistake I was taking that name. So you can answer it. What is the name of AWS cloud load balancer and what is the name of Microsoft server based load balancer? Then question number 3 is, you are required to load balance TCP. So you will be using which type of ELB? You will be using application based, or you can call it like a layer 7 or layer 4. Which one you will be using here? Question number 4 is, health check is not a feature of ALB, application load balancer. Do you think it is a true statement or false statement? Do you think ALB is doing health check? If yes, that means this statement is false. So you choose the right answer, and that was all in this particular session. So this was all about in this video, and I hope this video was informative enough for all of you, and I would like to thank you for watching.